Hi, I am Mr. Christian Lee. I am a college instructor and a mathematics teacher. If you are new to my channel, please subscribe and then put like for this video. So this time, we are going to have a simple video tutorial about the circle area approximation using the GeoGebra software. So this approximation of circle area was actually introduced by the Greek mathematician named Archimedes. So please watch and finish this video. Of course, as we start, we need to open our GeoGebra. Then we are going to click in the view, we are going to click our algebra and graphics. As you can see, we have already checked algebra and graphics. Then, since in this tutorial, we need to label all new objects, so we're going to click settings, then find labeling here, and then click all new objects. So right now, we are going to click, we're going to create our slider R. So as we create our slider R, we're going to click slider, and then click anywhere in our graphics view. Then our slider dialog box will come up or will appear just like this one. So we are going to name our slider as R, and then we are going to type in the minimum box 0.1, and then our maximum box is +5, and then our increment will be 0.1, and then click OK or apply. Alright, so as you can see, here's our slider R. So this slider R will serve as the radius of the circle that we are going to create later. So we are going now, right now we are going to create another slider. This time we will form our slider N. So same process. So click slider and then click anywhere in our graphics view. Then rename our slider as N. So in this case, our minimum box will be 3. Our maximum will be changed into 30. And our increment will be +1. And then click OK. So this N, slider N, will serve as the number of the sides of our polygon inscribed inside the circle. So now we are going to click point. We're going to put our point in our origin, and then we are going to make sure that it is intersected in our X and Y axis. And then to create our circle, we type in our input, let's type circle, and then parentheses, capital letter A, and then small letter I, then enter. Alright, so as you can see, this is our circle, and as we move our radius or our slider R, the dimension of our circle also changes. Now to construct point B, which is the intersection of the circle and the x-axis, we need to type B in our input. So capital letter B equals open parenthesis. So we will have R, or small letter R, and then 0. And then we are going to click enter or return on the keyboard. Alright, so here is our B. Alright, so at this point, we compute for the central angle of the inscribed polygon. So to do this, we divide 360 by n. For example, if we want to divide if we want to have an equilateral triangle, we must divide 360 by 3, which will be the central angle. So to do this, we need to type A is equal to 360 over n degrees. So let's type in our input A is equal to 360 over our n, and then degrees outside. So the degrees can be seen in our function, degrees, and then click enter. Now, to create B prime, we are going to click our angle with given size, this one, and then click point A, then click point B. So it will show the angle with given size dialog box, and then in the angle text box we are going to type A, and then choose counterclockwise, then click OK. Alright, well, for example, your R is set in +3, and then your N is set in +3 also. This is how our drawing will look like. Alright, so to hide this one, we're going to right click the degree and then show object. Okay. So now, to construct our Inscribed polygon, we are going to click Regular Polygon tool, and then click B, then click B prime. Alright, so it will show up our regular polygon dialog box. So we're going to change the number of vertices into n. So let's type n, then click OK. So as you can see, our n is set in 3, and as we move, this is what happened. Alright, so let's try to set our n to 30. So the problem now is, how are we going to hide every labels of these points? Alright, so that's very simple. We are going to click show hide label, and then click every labels of points one by one. This is to hide the labels of the points of our inscribed polygon. So just keep on doing this until we hide all the labels. S, R, Q. So this is very time consuming because we are hiding 30 labels of 30 different points. M, L, K, J, I, and H. Alright, so finally we had hidden the labels of the different points. Alright, so that's how it will look like. Alright, so this is how our figure will look like if our n is set to 29. Alright, so let's try to set our R to 3 and our slider n to 3 also, for us to have the radius of the circle equal to 3 and to have our inscribed triangle. Alright, so this time we're going to create tangent lines, and for us to create tangent lines, let's click tangents, then click point B, then click our circumference, or the circumference of the circle. So this is our first tangent. Now repeat the process, click our point, then click the circumference. Alright, so we have our second tangent line, and then for the third one, just repeat the process, and there we have it. Alright, so right now we are going to click intersect with 2 points, then click our first intersection of the tangent lines as well as the second intersection of the tangent line. So this time, we are going to right-click our tangent lines for it to be hidden. So just right-click and then uncheck Show Object. Repeat the process as to the other tangent lines for us to hide these lines. And now, we are going to create our circumscribed polygon. And for us to create our circumscribed polygon, we're going to create the regular polygon tool. And then, we are going to click our first intersection of the tangent lines. Then connect it to our second intersection. Then it will come up to the regular polygon dialog box. So we are going to change the number of vertices to n, then click OK. So that means that whatever the polygon that is inscribed in the circle, that will also be the polygon that will circumscribe it. Alright, so we are going to use our text tool for us to describe the area of our circumscribed polygon. Alright, so click anywhere and then we are going to use advance. Alright, then click this perspective view. Then we're going to click polygon 2 or polygon 1. Alright, so polygon 1. Then the area of the inscribed polygon is this one. So click OK. Alright, so the area. Alright, so just move it here. And then just do the same for our circumscribed polygon. So click text, then click anywhere in our graphics view, then click advance, click our perspective view, then find polygon 2 for our circumscribed polygon. So the area, we type the area of the circumscribed polygon is, alright, click OK. So we come up to this one. So we can conclude that the area of the inscribed polygon is equal to 11.69 and the area of the circumscribed polygon is equal to 46.77. Alright? So that's it. That is how easy we can get the circular or the area of the circle approximate using GeoGebra. Alright, that ends our video tutorial about the circle area approximation using the GeoGebra software. I hope you have learned something from this video. Thank you for watching.